Alright, so let's start going over functions and Golang. So what is a function? Well, the definition that I like the most is a function is a chunk of code that we can run over and over again. And honestly, we have been using a function pretty much this whole tutorial series, right? We have this function here called main. And this is called, or this is the central point that Go runs to run our application from the get-go, right? It runs, once we run this application, it runs anything within these curly braces, and once it executes everything within these curly braces, it stops, right? It does what it needs to do, and then it stops. It executes a chunk of code, and then it stops, right? And we can keep running that over and over again as long as we tell Go to run. So we kind of already been exposed to functions, or a basic version of a function to start off, but now we're gonna play around with adding things to these functions, and different ways that a function can be useful to us. All right. So one thing that people do on an everyday basis is math, right? Sometimes you might calculate mentally, all right, or physically using a calculator. Math, right? So let's create a simple function that will divide numbers that we provide to it. So to create a function, right, we just use the keyword func, func, and then provide a name that we want to use to call the function. All right, so main is a keyword that Golang, pretty much keeps for itself to know that it's going to call main when the application runs. So we can't use main, but since we know we're going to divide, we can use the name divide for the function. And we can open up these parentheses and then open up these curly braces to put in the chunk of code that we want to run when we call this divide function. Let me put some space so it looks a little bit cleaner. Now, we can't divide without actual properties, right? So let's do that. How do we let Go know, or let the function knows that we're going to take in numbers to actually divide? Well, we can start specifying it, right? So let's create a name on what we're gonna accept inside of this function, and we're gonna create a thing called parameters. Parameters are inputs that we're taking into the function within these parentheses. So the first parameter that I'm going to put is, let's put a, right? I'm gonna call this a, and I am gonna accept a float 32 because when you divide, you can always get decimals. So we should probably accept decimals from the beginning because we're probably going to return a decimal, right? And then we can provide a second parameter. All we got to do is put a comma, right? And we can put another parameter, and we're going to call this b, and then we're going to do float 32. This is just saying that we're going to accept in two inputs. One's going to be called a, and it's going to be of type float 32, and the second one, separated by a comma, is going to be b, and it's going to be also a float 32. Now, since both of these are float 32, we can remove the first type. So now we have a and b, and now Go can see that both of these parameters are of type float 32. Now, if they're different, like if you have an int, then you have to put it. But if you know that both of these parameters that you're accepting is going to be of type float 32, then you could just remove the type and just have it at the end. And you're not restricted to just using two parameters. This can be the same even if you're using 4 or 5 or however many that you have. So like this still works, but we only need two parameters, so we're gonna just take in two that are both going to be of type float 32. So let's do some math, right? But first we have to specify what exactly we're going to return back to the user when we do the math of dividing. Right now, we're not returning anything, right? We're not specifying a type that we're going to return back to the user. Right now, we're letting the user know that we're going to do the math, but we're not going to give them a value back. If we know that we're going to give a value back, then we have to specify the type that is going to be returned back. So to do that, all we got to do is put a space after this parentheses and put the type that we're going to return back. I expect to see a float 32 back, so I'll put that, and now we know that we're going to return a type of float 32 when the mathematical logic is done. So let's do the logic, right? Let's do return. All right, so if you came from a language like Pascal, right? Pascal probably doesn't require a return type or return to let the language know that you're going to return something back to the user or whatever called the function. But in Go, you actually have to specify, okay, we're going to return this value back after we're done with executing whatever chunk of code is within this function. So we're going to use the keyword return to return the value of the math that we're about to do. So we're going to do A divided by B. And after it finished calculating A divided by B, it's going to return this value, and whatever is being called from will now have the value of A divided by B. All right, so let's save this. So now all it's saying is that it's being unused, so let's actually use it, right? So we're going to create a variable called answer. So just do ans, and then we're going to set that equal to divide, and we're going to do 10 for the first parameter. So when we pass in, so they actually call the function, right? We use the name of the function, open up the parentheses, provide the first value, which is going to be a float, and this is going to be passed to the variable of A, or the parameter of A, and the second parameter we're going to put for when we're calling it is going to be passed to B, and then we'll do A divided by B, because now whatever we pass in is going to be stored in this. So if we do 10 for the first one, 10 is going to be stored in A, and if we do 5 for the second one, 5 is going to be stored into B, and whatever it returns is now going to be stored into answer. So cool. And we can fmt.print and then print out the answer. So 10 divided by 5, let's see what that is. Boom, 10 divided by 5 is 2, and we can see that obviously we're using ints here, but it's just going to convert it into a float, no problem. So it's really like 10.0 divided by 5, and it's going to return 2. So we're good to go. All right, so there is a case that this can kind of break, right? So say for somebody, maliciously tried to put in a value that they know will break the system, right? Like putting a 0 as the denominator, right? And if we run this, it's gonna make it plus infinity. Like we don't want that, right? Help check if someone's trying to put anything malicious. We could also do an if and check if b is equal to 0, right? Because we know that we don't want to have the denominator as 0, which b is. So we're not restricted to just using one line of code. We can use multiple lines of code, and before we even get to this return, we can do a check to see if it's equal to 0, if anyone's trying to do anything malicious. So we can open up this if statement, and if they are doing anything malicious and it passes this if check, we can return 0. Or, right, let's do something a little bit better. Go provides a way of returning multiple things from a function, right? That's one of the cool things that I actually liked about Go, is that you're not restricted to just returning one thing. You can return multiple. So to do that, all we got to do is wrap this return type in a parentheses and put the second thing that we want to return. So let's do error. We went over errors in the types for variables video that I created before, and errors is just wrapped. It's just wrapped in a string. So pretty much when we're going to return an error, we're just returning a message that is going to let the user know that this is not proper. So let's also return a new error in this if statement to let the user know, okay, this is not proper. We can't divide by 2 or divide by 0. So let's do errors, and I'm just going to import the package, which is going to let us create a new error, and I'm going to let the user know you cannot divide by 0. And here, if it is correct, then I just want to store nil for error, right? So if you came from other languages, this is like null or none for Python. It just means nothing, right? There's nothing that's going to be stored in error. But if there is an error, then we're going to put the float as 0 because we're unable to do it. Or you can even do -1 if that makes you more comfortable. And we're going to return an error message back. And now since this changed a bit, now it's expecting to return two things. We have to have two variables to extract from this function. So we're gonna have an answer, but we're also gonna have another variable called error to error to store the second type. So it can either be nil or it can be an actual error message. So we can also do a check, right? So if error is not equal to nil, then we can print out whatever we got. So we'll just do fmt print ln, and then we'll print out error. Else, right? We did a whole video on it, if and else's. So open that up and we'll print out the answer if anything. So this is a perfect way of checking and using functions in Go. We can take in multiple parameters. We can return multiple types. If there is an error, right, we can return an error. But if there is an error, right, we can return the actual answer and just provide nil as the value for error, meaning that there wasn't an error, and that we're good to go. And we can do a check after we retrieve both of these values from the function call. And if error is not equal to nil, that means we do actually have an error. So we will print that out. But if we don't have an error, like if error is equal to nil, then it's going to go into this else case and we'll print out the answer that was returned from the function. Pretty powerful stuff. So let's actually run this. Let me save this and clear this out. Run it. Boom. You cannot divide by 0. We had an issue. But if we, use 5, right, and we run it again, it's going to be 2, right? Because in this case, it's proper. So it's going to just skip this if statement and go right into returning what a divided by b is, and error is going to now be equal to nil. So when we extract the value from the function, error, which is the second case that we expect to return, is going to return nil, and it's not going to pass this case. So we can just fall back and print out the answer. So another type of functions that we have in Golang are anonymous functions. What are anonymous functions? They are functions with no name that must immediately be invoked, right? So let's actually see this in action. Let me just remove this, right? And let me create my anonymous function. So we'll use the keyword func, right? Because we need that to create a function. But we're not even going to provide a name. Just going to open up some parentheses and open up some brackets. And let's see. Let's do fmt.println, and we can say this is a mystery. And now to make this immediately invoke, what we're going to do is open up some parentheses here, and boom, we have a anonymous function, right? So now if I save this and I clear this out and do go run, boom, this is a mystery. It is immediately evoked. So we know that once we run a Go application, this main function is ran, and it's going to see this anonymous function, and it's going to run automatically. And if it's confusing why we put this parentheses after, if you remember, when we had to call divide, what we had to do is, call divide, pass in the parameters, so like 10 and 5. But you can see that you needed this, right, to actually run divide. But because it's, needing parameters, right, we pass into parameters. But really, if we didn't have parameters, you still needed, you still need these parentheses to run it. These parentheses just let Go know that we want to run this. But because divide requires parameters, we have to put the parameters in first, and then it runs it. So with the parameters that we specified. But in this case, since this anonymous function doesn't need any parameters, even though it doesn't expect any parameters, we still have to use these parentheses to let it know that we're trying to run this, and we have to immediately invoke the function with no name. It's anonymous. So that's how you create anonymous functions. Some people use it to call to connect to their databases and stuff like that. Honestly, I don't really use it that often, but just to let you guys know that it's possible. So another way that we can create a function in Go is to actually store the function within a variable. So let's actually do that. So we're going to create a variable called prompt, and it's going to create it with a type of func, and then we're going to set that equal to func. open up some curly braces, and now let's actually prompt something. So let's do a fmt println, and I am just gonna say welcome to the team. And to actually call this variable that's holding the function, we can just do prompt, open up the parentheses, and boom, we should be good to go. So if we do go run, we see welcome to the team. So there's many ways that you can implement functions in Go. We can have functions within using a variable like we just did. We can use anonymous functions. We can create functions with multiple parameters and that can return multiple types. And you're not even restricted to just using array. Like if you want to use another int, we could. String, if you want to return a struct, that's also possible. So yeah, you can do that. And a lot of people use this returning of one type and another type of error, especially used in it's really used in a lot in APIs. If you send a request and it doesn't return, or you don't get the response that you expect, you can return an error. So this is used a lot in Go, especially when creating APIs. But also here in this case, if you know that you're going to use two parameters of the same type, you can put in the parameters and then put in the type at the end, or you can just specify another type here if you know they're going to be different. And you're not restricted to just using two parameters. You can use multiple, or you could just use one. So my thoughts is use them, play with them. Try to add, create a function to add, or to subtract, or different things that you expect. Maybe even taking a name, print out welcome. There's a lot of things you could do with functions. If you know you're going to reuse code a lot, it's better to just extract it and put it into a function than just writing it over and over again within your main function. Doesn't make sense. Create a separate function, and take in the parameters that you expect and run that code. Remember, it's just a chunk of code that you think you're going to use over and over and over again. It's just a way of abstracting data and making it more clean and efficient. So I hope you guys enjoy. If you have any questions, let me know. Write it down in the comment section.